Welcome to an Archean coding video. This is part 1 of ground vehicle movement. And here we have a simple vehicle I created up. It has 4 big wheels. I have data ports connected to all 4 wheels. Only the rear wheels have power. And I've labeled all the wheels. Wheel rear left, rear right, forward, front left, and right. So in this case, only the rear wheels are powered, which also means during regen, only the last 2 wheels will generate regen. We have a simple RPG, and that's just to drive the computer. The computer has a router that we connected all the wheels, and so in case of the router, we use names. In the front here, we have our velocity sensor that gives it our speed indication. We only pull for speed, which is our z-axis, and then we have tilt, and that's just for right now for display, and we can see the tilt as we do a little wheelies here. Now, this demonstration, this first part 1, only supports going forward and backwards, braking, and with automatic regen when we're not accelerating. And anytime I say acceleration, that means either positive or negative. So positive forward, negative is obviously going backwards. So let's go ahead and do a quick demonstration. If I hit W, you'll notice the backward 4 will turn to 1, and we'll start going forward. And then you'll notice we'll start consuming battery. And I take when I'm not actually hands off the keyboard, we start slowing down, and you notice the charge delta is positive. That means we're using regen. Also notice that the regen doesn't put a lot of braking power on the vehicle. In this case, if I hit 4 and turn braking on, so the way I have it mapped is I have the number 4 key, auxiliary 4, for braking. Anytime I'm not actually accelerating, the regen is turned on by default. And we can do a little wheelies here. And if we do well and hit the brakes, it stops pretty well. Okay. So now let's do this with a Xbox controller. So we go forward. You notice now we get fractional. You don't have to go 0, 1. As I push down the trigger, so I'm using the right trigger for forward, I can control the speed. If I hit the left trigger, then that's backwards. And if I hit the left bumper, that's the brake. And so that's why I have it set up. So a little forward, a little backwards, and I can brake. And let's just go ahead and for a little fun here. And if I just slam it, I actually get airborne here. Now the spinning, I don't have any steer function in here, but you notice the terrain is sloped. And as I lift off here, I really just nail it. I'll get some turning. So it's kind of interesting doing this with no steering. And because I'm on the hill, I can actually kind of steer by going back and forth and based on the hill terrain. Okay, so we have let me hit the brake here so we'll stop. All right, back into the vehicle here. So that's simple enough. We go forward, we go backwards. The regen kicks in automatically. I tried experiments where I'm just I tried experiments with manual enabling regen, and just get up to speed, zipping along and turn on regen, and it takes forever to slow down to the point that I didn't even think I had it working right. And then until I verified it, and I verified by checking the battery. So I knew if the battery was charging, the regen was obviously working. Obviously, it would probably work better if I have all 4 wheels hooked up to regen, but it was pretty slow. And as you see here, if I accelerate up, and if I'm not accelerating, the regen kicks in automatically. It doesn't really slow down all that much. Now, I did whine about this on the Discord, and so we'll see if this is expected behavior or something they can change. Now, one thing I'm also not doing, I'm not messing around with the gear, so maybe if I, downshift it a little bit, that would help in the passive slowdown. And then with the keyboard, the brakes are like full brakes or no brakes. With the controller, you can do partial braking, which gives you more control. Now, the next video will do steering. So let's look at the code we have here. Get out of my seat. I can stay in my seat. Okay, so let's go to main here. So if you just want to do very simple, just wire up, the inputs from the pilot seat directly into, the wheels and drive that way. That does work. And the goal here was do something a little more sophisticated long term. So for example, to add the ability to maintain a certain cruise control, for example. I want to maintain a certain speed, set a cruise control. It just tracks that, and or maintain direction. You notice it slips twins left and right if I want terrain. So if I want to lock it in on direction, just have it sort of autopilot for a little bit. And to do all that extra stuff, then it would definitely need a nice good structure for doing that. Part of this code is for debugging and visualization, and so the stuff you see like on the screen here, the fact that I have regen enabled, brake enabled, you typically don't need to actually see that. I also structured this a little bit so there's a lot of includes here, and that's the goal of that is to reduce the mainline code here. So basically, once we kind of look at these helpers, we can kind of ignore it. And if you look into the wikis, it's kind of a mapping in the wiki. So what I did, for example, for the big wheels, I mapped out all the input channels. And its input for the component, its output is writing from your standpoint. So as this is input to the component from the code standpoint, we're going to set it. So these are all variables we can, properties we can set on the channels. These are the ones we can read. So we can set like the acceleration, the steer, regen, brake, and gearbox. We don't mess around the gearbox in this one. Maybe that was part 3. Here we get the output. We have the speed, which is rotation speed. If the wheel is in the air or slipping, it's obviously not the ground speed. We have the friction, which I've not played with. My understanding is friction is basically as if you lower the air pressure of your tire. So effectively, more friction will give you better grip, but it will reduce your maximum speed performance. So if you're just in a flat area, I'm not sure which way goes which, but probably the opposite way. So probably down to 0 or in very low will speed up on the flats. But if you're climbing up, you want to go ahead and increase that friction. Now in that case, you may want to change your gearbox and have higher torque and all that. But we're not getting to that right now. Baby steps. Now, I have the wheels on a router, and because of that, I can use names, and I have a naming convention. And you're not aware of this, if you put a star, that means all the wheels apply. So when I hit like on brakes, I just set it to wheels, which is wheel star. So all 4 wheels will get that command to brake. And I have all the individual, and I have like the front, on these front or rear and all that. So I put all this in this little file. This is for my helper I use in the future. So you kind of, and I have a prefix system. So BW for big wheel. And so that's if I see big BW, and then I see a set, then I know it's it's an input channel for the big wheel. Same way, these are names. So typically I use the word name for name values. So I use that. This is my convention. And then for the linear sensor, which we just use for the speed, we just have, and of course, depending on how you position the sensor, this is how I have it set up, different values. And then we have the pilot seat. So the pilot seat has effectively what these are is input, keyboard or controller or joystick inputs all go through here. And so I put some comments. This is my mapping. You can obviously map these differently. And so the plan is, so basically this is the map forward, left trigger, right trigger. And then for the brakes, I have left bumper. We don't shift gears in this one, but I'm going to use A and X. And then, of course, steering would be the joystick on the Xbox controller, which we're not doing it here. And, of course, a lot of these are for flight control, which we're not going to mess around with. Now, you can do a lot of arbitrary things in here, and the way you do it. So this is my convention, and you have a lot of flexibility. So now this is our tilt sensor. So it only has a single value, which is the tilt, and orientation matters. So it's facing away to with tilting if we pop up the front. And then we have the battery. We only use this, the throughput, that gives us our charge delta right here. And so basically if it's negative, the battery is draining. If it's positive, the battery is charging. I put this in, I have this in here just so I can have this display to verify that regen was actually regenning. We break out what I call debug helpers. Debug helpers effectively what renders the screen. So it takes some variables, gets passed in, and other variables it'll acquire directly from the device. So, and renders this. This is debug. It's not designed to be too fancy. But by putting it here, it gets it out of the mainline code, makes the mainline code a little easier. So let's look at the mainline. So now we kind of looked at these headers. We can sort of ignore these now. So we have the computer mapping. This is how the computer is mapped. Here's our computer right here, how it's mapped to various components. So there's two ways of communicating with components. We have what I call direct wire or port. So you connect a data line directly from the computer directly to the component. So that's called port. The other way is by name. So if you connect, if it goes to a router, then you can use names. And so for just because I have the battery on the router, I could have put the battery directly on the computer and made it a port. I just decided to put it there and gave it a name. In theory, I would think about having one battery for the front wheels, one battery for the back wheels. Obviously, you can drive it all from one wheel, one battery if you want to. My understanding for regen to work, the wheel must be directly connected to the battery. There cannot be any junctions or anything else in between it. I've not verified that, but that's what I read. All right, so we have, this is basically we got headers, we got definitions. We don't have any init. In this case, we're doing it every tick. So we grab stuff that we're going to need. So we grab from, once again, PS, and of course, I have port seat. So we know we're grabbing a port seat value. So this is our forward and backward. We're grabbing. We grab the handbrake value. So these are the two inputs that we need to actually control the vehicle, front and back and brake. Then we grab speed, we grab the tilt, and we grab the charge. So these three are really for debugging. So I could have renamed those at some point, debug. The next version, I'll remove this, probably clean this up a little bit, remove that. All right, so here I do a simplified state. And so basically, if the value break is not 0, then we're breaking. And instead of hard putting this code, that expression in the main line, in the logic code, I'll just use is braking as a value, and same with acceleration. So basically is braking and acceleration. It makes, for me, easy to read the actual logic. So typically the way I do things is I get all the inputs, I compute a lot of state, conditions in state, and then I have the main logic that actually does the intelligence of what to do. And the goal is that this main logic, which is typically the hardest part, you want to make that as simple as possible and get as much code out of there as you can. And because that's where you make decisions on what you're doing. So right here, all the decision making is being made right here of controlling the actual wheels. Everything else is basically acquiring information or setting state. And we'll skip over the end. This is where we have our debug render input, which are, that's not really the correct name. It's really render state. It's really the current state, which includes inputs. It initially was just input, so that's actually incorrect definition. So the description was actually correct. The name is poorly written. All right, so let's get off the debug stuff. All right, so now we do the logic here. So we start off with is braking. So that makes sense. Once again, for me, it's easier to say is braking than and doing that. Yes, it does burn a couple instructions, but we got a lot going on, so it doesn't really matter. So if we're braking, that means I'm holding down the 4 key on my keyboard or using the left bumper on the controller. We'll go ahead and take the brake value. Now the brake value from the keyboard will be just 1 or 0, but for the controller you will actually have floating point from 1 to 0, so you want that. I also kick on the regen because I figure why not? We're braking, so if we can get a little bit of juice out of the system, then it breaks pretty quickly, so it's really not really worth doing this. You don't get that much out of it, but I just did it for fun. I set the debug flags, and these flags basically determine if it renders here. So I initially set them to 0, and if I turn them on, I set them here, and I just a rendering function there. So then we come down in here. So that's all we do for braking. If we're accelerating, now in this case, I could have used the name version with the star. I just did these separately. It doesn't really matter. And the way all this stuff works is that this is all tick based. So basically everything gets set and applied, and then a tick gets performed. So it doesn't matter if you make 2 calls like this in the same tick. As long as it's the same tick, it doesn't matter. It's all going to apply at the same time. So we output basically both wheels. We set the acceleration, the value, what the acceleration is. We just do it directly. And then in this case, the brake. Now, if we look back at our big wheel helper, I made a comment called sticky. A lot of these values are, you set them, like you set acceleration in one tick, and say the next tick you don't set to anything. It reverts back to 0 automatically. So it's not like you set acceleration, you leave it and have to set it back to 0 at some point. No, you just set it, and then the next tick, it gets reset to 0. So some properties, some channels are sticky and some are not. So in this case, the brake is sticky. If you turn the brake on, set the brake, all future ticks, it will stay on. That's why I set the brake to 0. If I didn't have this line wasn't there, I hit the brake, it would no longer accelerate because the brakes are applied. Like my pickup truck, where I can actually still move the truck with the brakes on. But in this case, we can't do that. We don't have enough power. So we make sure we turn the brakes off. And then if we're not braking and we're not accelerating, then we go ahead and we turn on regen. Now this is actually a bug because right here, let's fix that there. we need to set this, sort of the plus side of describing your code. So we have a condition that if we went into braking condition, now if we're in braking condition, we're probably stopped. And we're not accelerating, we fall here, we want to come out of the braking condition because we're not pushing brake anymore. So I should reset that to 0 there. And we turn regen on, and then we indicate we got regen going, and round and round it goes. So this build, let's save this for now, is, and that's the code. So what I'm going to do is I'm going to put this vehicle in the workshop. So you have the vehicle and all the code, and you can drop it into and play around with it, make changes, whatever. So this will be sort of be listed under, I'll put the description of what I'm going to call it in the description of the video. It'll be something like, you know, GroundVehicle coding part 1. And so this will be the part 1 vehicle. When I update the vehicle in the next version of the video, when I add steering, that'll be a different vehicle, different coding and all that. So this is a simple way. Now I use big wheels. You can use the standard wheels too. The standard wheels and the big wheels have the exact same settings and configuration and output. It's just the standard wheels can use a normal low voltage power source, or they can use a high power, and of course they're smaller and not as powerful. This is in creative mode. I just dropped the large ones in here and doing that. So, oop, not V, I want to hit K. Okay, now we're pointing to, let's go backwards. Now I had no steering, so I can't actually turn. I want to go in the water. Oh, and if you do go in the water, and it will, if this vehicle currently floats and the wheels are partly out of the water, but the wheels spin, and you can see the wheel spinning, it does not give any level of propulsion. So you're basically, I was hoping that with the wheels in the water, halfway in the water, that it would go like really, really slow, but apparently not. All right, so my Xbox controller turned itself off. Let's see if we require. Okay. Yes, hit it. Not getting any air. There we go. There we go. Probably a different angle for this. It's because we have a big flat surface. That big flat surface is basically I hit the brakes and flipped it because the brakes. Okay, let's go back to thing. I think I can flip it back over, but just. All right, there we go. So one thing I need is anti-traction slip on here, so I can keep maintaining a straight line. Hit the brakes right here. And this is some of the really advanced stuff you can do. Like for example, there could be logic in here that if I'm going forward or backwards, and I'm not applying steering, then maintain a straight line to sort of deal with that traction loss. Something else also that's been in the suggestion list is that the suspension system, there's no way to read the suspension, how far the suspension is loaded. So we're hoping that this value will be exposed in code, and then if one wheel is in the air, what should happen is suspension load should go to 0, and you'll have an easy way to tell if the wheels are on the ground or not. I guess in theory you could put a sensor on the bottom here that reads the distance between here and the terrain. And if it's really in the air, you'll know that because it's real close. So that should be, there's going to be like a little, probably a little area where it's just off the ground, but you won't really know it's just off the ground. But that's a workaround. But we're hoping that we'll get suspension loading added to the wheel property so we can pull that out. All right, so we'll call this the end of this video. And next video, we're going to add steering. So the goal is sort of like kind of push this further. So in part 2, we'll add steering. Part 3 and part 4, you may get fun, like add a wheelie option, where once you hit like a tilt of, we'll call it, I don't know, like 40 degrees tilt, we'll put a toggle switch to enable the mode. So basically, if you wheelie up to 40 and this toggle switch is on, it will maintain the wheelie for you. So you can basically take your finger off the acceleration, and it'll just maintain the wheelie going that. Another one, we need to deal with maintaining a straight line, and that we'll probably use a pig controller for that, so we kind of so we don't slip around too much driving. All right. Until later, bye.